Hi there. Welcome back to another lesson in BCIT, Technology Teacher Education 5060, where we're taking a look at tethered mini sumo robots and how we managed to turn some traditional metalwork material and content, working with sheet metal, into a fancy high-tech robotics project for your students. And in our last video, we talked about creating the orthographic drawing using traditional hand drawing skills. And today we want to take a look at how we go about creating the sheet metal parts that we're going to need from this design. If you've done work with sheet metal before, you're familiar with layout drawings and bend allowances and all that, and you can probably just go ahead and get to work. But if you haven't done a lot of work with taking an orthographic drawing and turning it into something physical so that the parts actually sit together, and we've got 1-to-1 scale here, that matches up right there. It matches up right down here. Then I'll walk you through the process, and this is what you can get your students to do to create some drawings that will make their robot fairly easy to assemble. Okay, now one of the things that before I get into this that I am going to talk about is I did what was a little bit of bad drawing technique here when I made this line right here. Let's just make sure that's focused in there, thick, and doodle that in. And that's because the sheet metal actually has thickness. And around the corners here, you'll see that I also sort of sketched those in as a bend, because even when you do a really tight bend in sheet metal, it ends up going around a curve. Okay, it's not like bending a piece of, well, technically pieces of paper do that too, but the bend radius is so small that we don't even notice. In sheet metal, and particularly if you're starting to work in heavier gauges, or if you're moving on to work with band iron or thicker things, you do need to take those bend radii into account. Now, in classic sheet metal work, there's a number of formulas for bend allowances and setbacks and things like that. And that's really worth knowing and going back and referring to your textbooks. But if you're doing this with grade 9 and 10 students as an introductory project, you probably don't want to delve that deep into the world of sheet metal design. So you just want to give them some good guidelines so that they can have an idea what they're talking about. Now, one of the things I did just to get familiar with our tools and make sure I'm giving you good advice that's going to work here at BCIT was I went and took some measurements and did a couple little experiments with the box and pan breakdown in the machine shop, just to make sure that my rule of thumb was going to work. So first of all, most of our design is going to be done using 16 gauge aluminum, and you can look that thickness up on a chart. I usually say 1.5 millimeters, but right in there you can see if I measure that, it comes out around 1.6 millimeters thick. So we're going to want to use that and just keep that in our mind, because what that means is that when you go and create a bend right here, if you're looking at outside dimensions, well, right in here, I measured from the fold line to this end to be 100 millimeters. And then I carefully scribed that in there. And on this side, I measured 30 millimeters from there to right there. Now, in working with paper or something like that, when you make that bend, then the outside dimension from here to here would also come out at about 100 millimeters. But if you measure it on here, because you've also got, open that up a little bit more, right in there, that comes out to 102 millimeters. Okay, because you've got the additional material sitting right out here, as well as you've got a little bit of a bend happening right in there. So we've got to allow an extra couple of millimeters every time we go and we create a bend. Likewise down here, this side that was 30 millimeters to the bend line ended up coming 32 millimeters to the end right out here. So let's keep that in mind while we go about and start designing our robot. We're going to start with the top right here, this piece right up here, the battery box sits on right there. And as you can see, I've already gone and made one just so you can get a sense for what we're talking about and how it's going to come together. It's going to sit right here, and these parts are going to line up with that bolt down below, hopefully, if we get it all right. Okay, now I'm just going to double check and show you what the sort of tolerances we can get by being careful about our measurements. Here's the battery pack that goes in here. When you're putting battery packs with batteries into your robot, be really careful that you don't leave these terminals exposed. If you touch these two terminals onto your aluminum, your batteries will be short-circuited, they will heat up, you will destroy your batteries, which is why I never buy batteries for my students. If they're going to destroy batteries, I want it to be on their own dime. And so make sure that's covered up really nicely and that you're not shorting out at this end of the wire either. It's an annual event that I have students melt battery packs, because what will happen is they'll slip this in here, they won't have their terminals covered, or there'll be some kind of short circuit, and lo and behold, they'll end up having a short circuit. The batteries will heat up, it'll melt the battery pack, and they'll have this big thing of black icky goo. And you'll notice that we actually have that in there nice and tight enough that we have a little friction fit for the batteries. That's going to sit right on top of our robot like so, or right like that. And when we want to get the batteries out, we can just give it a, oh, that's in there sturdier than I thought. Couple little taps, and the batteries come right back out. So you can do some fairly precise design work without too much effort in your sheet metal. Okay, so just looking at this, where did we start with? Well, I sort of started with this side right here and said, okay, this has to align right here, and this piece is going to be right here. This piece right here and this piece right here are determined by this side view, and then we can kind of interpret what the front view is going to be from this piece here and this piece right here. This one's a fairly simple one. Let's just move this off to the side and let's get started. So again, when you've got students doing this, you're probably doing this on a different day than you did the first drawing. So remember to send them to the sink or wherever you've got to send them to wash their hands. Give them some, maybe a bit of Windex and paper towel to wipe down their tools, and make sure everything's nice and clean, because you want your stuff to look good. And even though the students are sometimes a little hesitant to do it, they're sure a lot happier to get nice looking product coming out at the end of the day. Okay. And again, I just like to tape my workpiece down. It keeps the squares from grabbing on the corners, if nothing else. And certainly if you're using a T-square, this is brilliant, because you can get your piece of paper squared up once to the edge of your table using the T-square. And in my case, I can move the camera over here to make sure that's still aligned, and everything stays lined up. Okay, and because this is going to be a working drawing, I'm not going to worry so much about the border, but I am just going to put my name and sheet metal layout battery pack, and today is January 2nd of 2021, keeping our fingers crossed for all sorts of good news in 2021, because whoa, 2020. Nice knowing you, 2020. Alrighty, let's take a look right here at where we're going to get started. So right up here, if we take a look at the outside measurements of the battery pack, we want our outside to come to, we measured out 40 millimeters right on there. So what we actually have to do is we have to take about 1.5 or 2 millimeters off on each side to account for the bend radius, so that we can put our bend line 1.5 to 2 millimeters inside on each side. So I'm just going to come along right here and start with one edge of that fold. I'm going to square it up nicely to the edge of our drawing. And since I'm going to draw a couple of parallel lines in here, just putting this right here so I can slide it up and down, and there we go. And I'm not too worried about where I put that right now, because what I'm going to do is I'm going to come along and measure down here. Now, on the first side where we do our bend, we want this to come out at 40 millimeters. So our bend line, I'm going to mark in here and take a 2 millimeter bend allowance off right here. So let's start right here. And okay, I'm on 17 and measure it roughly vertically. So that's going to be 10, 20, 30, 40. That is what I'd see if I saw the outside. Okay, I'm taking a 2 millimeter bend off for the bend on this side and 2 millimeters off for the bend on the other side. And I'm going to stop it right there at 36. And come along, draw a line right in there. And then again, assuming our sheet of paper is nice and square, come right in there. Okay, so this dimension right in here is actually 36 millimeters. And I went with 36 millimeters because by the time I bend this side down right here, it's actually going to come out to right there. And by the time I bend this side down, it's going to come out 2 millimeters wider. And we're going to have that 40 millimeter outside dimension that we measured. Let's take a look at the top again right here. And now the top, there we go. Get back to our good scientific units. The top we measured out to be, how long? 65. So again, coming off the top, I need to come in 2 on that side and 2 on that side. So to our bend line is going to be 61 on the top. And get a nice precise measurement. I don't always start at the end. I just have to remember that I'm measuring out to 71 right now. Measure twice, cut once, there's 61. And since you are actually going to use this as a working drawing to create your sheet metal, you want to make sure that you do a nice job of, a little piece of tape was getting stuck. I may have to retape that corner. Anyway, we did this one to 61 because ultimately we want that to come out to 65 by the time we've got this piece folded down and this piece folded down. Now, the other neat thing that we've done right in here by being careful and making sure that we've got everything nice and square is that we've also marked off 4 pieces that are going to come off right in here. And we can come back and we can measure the height that we want to get on that. And the height was set up in this view right here. And so measuring from the top right there down to the bottom, we measured that at 1, 2, 3, 32. Okay, so if we measured that 32 and we take off a 2 millimeter bend allowance, that's going to come out to 30 millimeters on each side. 1, 2, 3 right there, and 1, 2, 3 right there. Now, you can take a look and say, well, there is going to be another bend right down here in this corner. Where'd my sample get to? So you can see right in here on this piece, because there is another bend right there. When we fold that over, technically I should probably be pulling this edge back another 2 millimeters to allow for that bend to sit flat with the front and back on here. But because of the technique that I'm going to show you when we actually go to make this, where I punch a hole at each of my inside corners to allow, just makes for cutting to go a little bit easier, having a rounded edge right in there lets you deburr those corners a bit easier too. I'm not going to worry about that right now. So let's go ahead and mark these in here. Now, if you were only making one of these and you weren't worried about mistakes and you were really comfortable with what you're doing, you could do this with a square and a scriber right onto your sheet metal. And, honestly, if you've done this a few times before, that's probably what you want to do. Okay, so now we've got a fold line that's going to happen right here, fold line happening here. These are going to be cut lines right here. We'll come back and clarify that a little bit. You can see I'm not too worried about going over a little bit right here on the ends. It's not that big of a deal. Okay, and the front and the back are also going to come down 30 millimeters because it was 32 that we wanted, but we allowed 2 millimeters for this bend right here. So 1, 2, 3, that'll come to right there, and 1, 2, 3, it'll come to right there. And let's go ahead, square this up to the edge of the paper. Put our T-square down and line it up nicely. And there we go. That's going to be the front and the back right there as well. Now we've just got a couple little tabs to add in right here. And if we take a look at this drawing right here, we can measure where those tabs are going to be. And those tabs are going to be located, if I go to the outside right here, this is where we have to be a little bit cautious because we've taken 2 millimeters off at the back. Okay, and this bend line right here is actually going to be pretty close to the inside right here. It's lost that 2 millimeters that we've got coming around the bend. So close enough for me. I'm going to measure from the outside right here and then just subtract the 2 millimeters for that one bend that we have. That shows that I'm 10, 20, 25. I'm going to come 23 millimeters in from right here. What was I measuring to right there? I forgot, was that the middle line? Yeah, 25 to that middle axis line, so 23. Let's just come right in here, and there's our 25, 24, 23, and then we did 5 millimeters on either side, and there's no bending right here, so I can go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, and let's just mark those lines right in here. We'll come right across like that. Those come up and down right on there. And we said that those were going to come out. How far did we measure that? 1 centimeter from the edge. That looks like about 1 centimeter in right there. And we'll bring them out by 1 centimeter and then round them off. So those are coming out on that side and on this side. One centimeter there. 1 centimeter right there. Square everything up to the edge of the paper. And there we go. That should put that tab right in there for us. Now, this gives me a rough idea of where I want that hole to be punched in there, but I'm actually going to do a little bit of a trick, and I'm going to wait until I actually have the bottom of the robot all built, and then I'm going to come back and use a transfer punch to mark that hole right on there. And it'll guarantee that everything will be a bit perfect. When you fold things up, you can sometimes save yourself a little bit of work by thinking ahead and thinking about that you're going to possibly make a mistake at some point. Okay, so let's finish this drawing up a little bit by coming along and just highlighting our cut edges. Okay, now right here, you'll see later on that I am going to punch a small hole at each of the inside corners. And that's going to make things fold up a little bit nicer for us. This is going to come down right in here, and it's going to come out. We want to radius or chamfer this corner a little bit. So chamfering it goes a lot quicker when you do it in the shop. Chamfer is just a flat edge, but I've drawn in a fillet or a radius on there, a smooth edge. Takes a little more work to create that. This is an outside corner. I'm not worried about hole punching right there. Inside hole. I can get my head in there so I can see what I'm doing. Got this camera in my way at times. Inside corner. Now, one of the reasons I'm marking it in nice and dark for the outside edges is because we're going to be photocopying this and using the photocopy to serve as our working drawing so that we can go and transfer that photocopy directly onto our piece of aluminum and create this really relatively simply without having to use a scriber or anything. And right along here, this will be a bend line. And there's actually a proper pattern for bend lines, but we'll just make sure that's marked out nice and clearly. And if you extend your bend lines off of the page a little bit, that sometimes helps you align things onto your box and pan break or whatever technique you're using, because you can use these lines right out here to help line that up into the fingers when you're putting it in there. So there you go. We've got that all put together, and we're going to fold all this up. These two will fold down, and we'll end up with something that looks about like this. Okay, so there we go. That's one part of our Sumo, and I will take that off and we'll do some sheet metal work with it in another video in a couple of minutes. Now, if you've done your drawings inside CAD, a lot of CAD programs have the bend allowances all built in. You tell them what material you're working with, and they take care of that 2mm allowance, setback, whatever you want to call it, for you. Okay, so there is one part that's going to come together. Let's take a look at how we're going to build the bottom part of the chassis. And there's one tricky part that we have to worry about right on here, and that's this piece right here. And it's tricky because it's at an angle, but because it's only in an angle in one of the views, it's going to be fairly easy to do. If you have something that's an angle in two different views, you need to look up more information on true length lines. And if you're really interested in learning more about this, you want to take a look at intersections and developments. And that takes a look at how you can use sheet metal to create round, smooth, curved objects, and how you can design two different smooth curved objects or to transition into each other so that they meet up neatly. And it's pretty easy once you know how. It's actually really amazing. Uh, it involves a lot of the use of your compass, so make sure you got a compass around or at least a set of dividers. But it's definitely worth doing once in a while. And certainly if you're teaching a drawing class, I had a lot of fun coming in and working with my uh, engineering 11 and 12 students, really mathematically gifted students. I'd give them this challenge where I'd say, okay, you've got a cylinder going in this direction and a cylinder going in this direction. You want to fold them up out of sheet metal and make it so that their two ends meet. What shape do you use? And very few of them could get it. And then when you show them how it's done, they're just like, oh my God, that's so simple. And it's simple in a beautiful and elegant way. So intersections and developments, a really neat part of classic tool, drawing and design tools that I'm not getting into today, but definitely worth looking up. Okay, so now we want to build this shape right down here. And as you recall, we didn't purposely didn't build it out to 100 millimeters because we've got a 100 millimeter by 100 millimeter limit, and you want to stay under that limit. We built it out to be 97 millimeters. Now we're going to have a bend right here and a bend right here. So I am going to take 2 millimeters off of each side. So 97 minus 4 will give me 93 millimeters for where I'm going to put the bend line. Let's square this up and give myself a nice square line to get started with. Okay, and I'm just going to pick a corner right there to get started at. And oh, what the heck. Let's come in right here and there we go. So I said I wanted to come down 94 millimeters to get my 97 wide. So $90, 1, 2, 3, 4. Now, if you just drew it out to 100 millimeters by 100 millimeters and did your bending, you would have a problem because you would be oversized by about 4 millimeters. You'd be losing a lot of marks on that on your design. Might not even be allowed to compete if it was more than 4 millimeters oversized. Okay, there we go. And so that is going to be this side from here to here. And now at the front, we want to know how far is it going to come from the back edge to this front line. Now those are marked on the outside of the bends. So we'll measure that. Outside of bend is 70 millimeters. We'll take 2 off at each end because we've got a bend front and back. So 70 minus 4 will be 66 millimeters to that bend right there. Now the bend at the front, because it's not a full 90-degree bend, I think I'm actually only going to take off 1 millimeter for that one because it's not bending nearly as far. So there are formulas and tools and all that, but again, we allowed ourselves a little bit of range in here. Our bending skills are such that we're not exactly achieving industrial level tolerances. And there is our top square that's going to form this top part of the robot right in here. Now, let's do this front tab coming off right here first. And you can see that the front tab, its true length is actually going to be this length right in here. Okay, and I'm going to risk leaving it just a little bit long because we want that plow to be touching the ground smoothly. And so I'm only going to take off again 1 millimeter on its bend radius. But if I take a measurement right in there, that tells me that this is going to be 43 millimeters long. In fact, I think I'm going to put the full 43 in there, and if I'm too long, I can always file it down, but it's important to me that that plow fit to the ground smoothly so I can get underneath other people. I want that to be sharp. I want it to have good contact with the ground right in there. So I'm going to leave it just a bit long and worry about taking it down to size later on. So that's going to be the plow up at the front. And at the back right here, our vertical dimensions are going to be, let's measure down from the top right here. What did we say that was going to be? 34 right in there. Yeah, I think that's 34, so subtract 2 is going to give me 32 is the distance that it's going to come down right in here. 1, 2, 3, 32. Like so. So of course this is quite a bit shorter than up front because up front it's coming down at a slant. And again, if you've got a slant on this side and a slant on that side, want to figure out them out the right side so that they match, you're going to have to go back to the textbooks and look up developments. True length lines is probably the term that you want to look for. And you can do it. Just takes a little bit more thought than I've got time to put into this video. Okay, so now we've got our sides come down right here, and our side's going to come down like this. We're going to have this slab right here that's going to be the same 32, but then we have to figure out the exact dimension for the front right here. Now, one of the things you'll see about that side is if it comes down 32 right in there, when it comes down out here, it's coming down slightly further than 32 because it's coming down all the way right out to here. So from the fold point right in here, we want this to come down. Let's see right here. It's coming down to the ground. And that is going to be, let's see right here, from the top down to the ground on this side. Let's swing this around so I'm not butting into the camera. From the top down to the ground was 35 right here. So yeah, out here we're coming down 35. So this is going to come down at this point out here by 35. Now there's no bend right here. This is going to come down over this edge right here. So I am going to take 2 off for that bend, but this is going to come down 31, 2, 3. Oh, it's not that point there at all, is it? Darn it. Got to be more careful on what I'm doing right here. I'm measuring from this fold right here at the back. This is going to be this inside line right here. That's going to come forward. I want to come to the inside right here. That's going to come 93, let's say. So coming off the back right here, it's going to come 91, 2, 3 forward. Okay, and from there I'm going to come down 35. Mark that because it's going to be symmetrical on each side. One, 2, 3, 35 to that point right there. And 2, 3. Oh, I said 33, pardon me. Take that back. I forgot to allow for my 2 millimeter of bend allowance because there is a bend happening right there. 1, 2, 3, 33 right in there. So that point right there, this one was off by just a bit. 1, 2, 3, 33. Bring it right in there. Okay, so that piece is going to come right in there like so. This piece is going to come right in here like so. Okay, and another way that you could have done this and worked it out is that we know that this piece right here needs to meet up with this piece right here. So hopefully, if I've done this right, that line meets up pretty close to that line right there, because when that folds down right there to meet it, those two are going to meet together, and that looks pretty good to me right in there. You'll notice that I've intentionally left this side just a hair shorter than this side because, like I say, I want to be able to file this edge down and sharpen that edge up. That's not really a sheet metal thing per se. That's just having done this once or twice before and thinking it through so that everything meets together. If you've got a compass right there, it does really help for transferring some of your dimensions, because when you know how long you want this to be, and you know you want this piece to match up right there, you can just take that dimension right there, and you can take that dimension right there, and you can put those right on there, and then draw that in and say that piece is going to come from right there to right there, and this piece is going to come from right here to right there. If I've done that right, that should be ever so slightly off square from everything else. It should. And there we go. Oh, just a minute. My measurements were a little off square. Should come up just a little bit, because when that folds down, I want the wheel to be sticking through underneath right here. Looks like we're still going to have enough room for that wheel to stick through. Just a little bit worried about that. So I am going to take an extra millimeter off on this side right here. Yeah, we'll build it that way. We'll sort it out when it comes time to build it in the final one. The idea of this is that we get close enough that we can make it all work. Obviously, you can get absolutely perfect, but now a couple of places where you're going to run into issues is cutting something like this out. We'll talk about that when I talk about how to make your sheet metal parts, because there are some ways to get in there and cut that out nice and easily. Okay, inside corners marked with a circle because we'll hole punch them right there. Fold lines lightly marked. And extending off the edge so that we can align things onto the box and pan brake. There we go. Now, we do have to match this up with our actual gearbox. So the gearbox will sit inside right in here. Okay, and what we're going to do to make that happen is just along that axis where I want the where I want these to go. I'm just going to measure in from the outside edge at the back right there. Well, let's measure. Outside edge at the back is going to that middle is going to be 1, 2, 25, 26, 27 from the outside edge at the back. So I'm going to measure in about 25 right from right here because there will be extra material out at the back. 1, 2, 25, and line this up. Right like so. Just put a line right in there so that when we come on later, we can put this right in here and get it lined up where we want it to be. And then I am also going to mark the center line right here so we can get it aligned. And again, like I say, I'm going to use the transfer punch to get this all aligned in here and do some of my hole punching because that guarantees an absolute perfect fit and you'll be happy with what you get. So let's just come in right here. We measured this one out to be 95 right in there. And so half of 95 is 45 plus 2.5 is 47 and a half. There's a center line right there. And there we go. Just to mark that out and give us a bit of symmetry for aligning things a little bit later on. Okay, gee, I hope later on when we put that all together, that fits on there pretty nicely. I think it will. So we now have 2 drawings set up and ready to go for the 2 parts that we're going to need to make our robot right here. So we have an orthographic drawing and we have layouts for each of the 2 parts. Marked with fold lines, little holes at all of the internal corners, so we remember to center punch and punch those out. And I think we're ready to go and start building a robot. So I'll take these, I'm going to photocopy them, and then I'm going to do a different video showing how to put the actual robot together.